Hi. Somebody tell me, audio, video both are clear, everyone? Somebody just check it. Audio, video both are clear, all of you? Right. Audio, video both are clear, everyone? Everyone, audio, video both are clear? Right. Now, so this is all formula revision of which one? This highway engineering. Will be continuing our discussion, right? What we were discussing in the previous class, if you just remember, we were discussing about this payment, na? So no, we were discussing about this payment design, because right, that flexible payment design we were discussing in the previous class, if you just observe, right? Yes, now, right now we'll be continuing our discussions, right? We'll be continuing our discussions, you can say, right? All of you, welcome to Unacademy. Let's crack it, right? Everyone is ready to crack, all of you? Are you all ready to crack, all of you? Yes, get ready, everyone, right? Everyone get ready to crack, right? Everyone get ready to crack. So whenever you are subscribing for the pleasant iconic courses, right, don't forget to use my referral code RP Civil Dive, right? Yeah, Abhilash Learning, right? RP Civil Dive is my referral code. You have to use, all of you, okay? Right. Recommend this code to all your friends and juniors, everybody, right? Those who are willing to subscribe for the pleasant iconic courses, okay? Right, this is my profile. You can find this profile, right? Rahul, good evening. Right, this is my profile. You can follow me at which, and if you are following my profile, okay, share this profile to all your friends. If you are not following, follow my profile, right? Rudra, okay, very good, right? RP Civil Live is the referral code you have to use, right? These are all the plus courses I am taking. At present, this RCC PSC is going on in the evening, and in this transportation airport engineering is going on at 3:30 p.m. right, like that. And this is a Republic Day offer. Today will be the last day of this offer, all of you. Whenever you are taking a plus a subscription for more than 1 year, you will be getting this 6 months extra subscription, right? You will be getting 6 months extra subscription, right? And along with that, when you are using the referral code RP Civil, RP Civil Live is the referral code. If you are using, further 10% discount, right? So don't miss this opportunity, all of you. Only 3 hours time is there at 9 o'clock, na? 10, 11, 12, right? Only up to 12 you are having this opportunity, right? Don't miss this opportunity, all of you, okay? So if you are having RP Civil Live is a referral code you have to use, right? So if you are having any doubts, you can just contact me at this place and subscribe to the pleasant iconic courses, all of you, okay? Right. So are you all attending this mock test? Don't miss this mock test, all of you. January 2nd to January 30, every Sunday you will be having this mock test. Don't miss this, right? So this is combat. January 30th is the last combat test for this month you are having, right? Top 100 participants will be getting which one? This some amount of scholarship they will be getting, 100% scholarship possibility, and Samsung tab, JBL speaker, Amazon vouchers, right? These are all the things you will be getting, you can say, right? These are all the new batches starting. Whenever you are subscribing for any of these batches, use the referral code RP Civil Dive, okay? Don't miss this, right? These are the civil batches, latest civil batches, you can say, right? These are all your latest civil batches we are having, right? Like that. So you have to be careful, right? So now coming to this, right, what we were discussing in the previous class, if you just say what we were discussing in the previous class, right? A long gap has come now. Actually, that last week the classes were not scheduled, right? Okay, let it be. Before second week of January only, these classes were scheduled, if you just remember. Yes, na? So I'll just go from the previous one. This is 27th, right? What we were discussing, we just observed, right? This method, design of this CBR, design of this flexible payment based on the CBR method, na? And this modified CBR method. And what else comes into picture? Yeah, this fatigue cracking and fatigue life. It's not fatigue cracking, fatigue life we have discussed, right? Rutting failure and rutting life we have discussed, it's not. This is 270, right? Up to this we have discussed, right? Isn't it, everyone? So that vehicle damage factor, right? What else we have discussed in the previous one? This vehicle damage factor calculation also we have seen, na? So this is your cumulative standard axle reputations we have seen, yes, na? Cumulative standard axle reputations we have seen, and this lane distribution factor we have seen, right? If you just observe, right? All these things we have seen, if you just say, right? Like that. So now we'll be continuing our discussion, right? We'll be continuing which one? This is our discussion onto this, okay? So this is VDF, right? Vehicle damage factor. You can say all of you here written already. Now, so 270 formulas got over now, and now we'll be entering into which one you can say. Now we'll be entering into which one you can say. If you just observe, right? This is your lecture 29 or part 29 all formula revision, right? 271 you can say, right? 271, right? What is it? 271 you can say indicative values, right? What are that? IRC 37, right? IRC 37 means flexible payment only, no? IRC 37 2012 VDF values, right? VDF values, right? IRC 37 has given some VDF, vehicle damage factor values, right? We'll be considering these vehicle damage factors now if we just observe, right? What are these given? Initial traffic, right? Based on this initial traffic they have given initial traffic in terms of what? That commercial vehicles per day only, no? Yes, in terms of this commercial vehicles per day CVPD only, right? And what is that you can say initial traffic, and based on the terrain these VDF values are given. Which terrains we are having generally? Well, the two types of terrains we are having. If you do not know anything, you can use these values by default, right? If you do not know anything, we can use which one? We can use these values by default if you just observe, right? So what is the initial traffic? It is 0 to 150 CVPD. Next one, 150 to this 1500 commercial vehicles per day. Next, what is the third one? You can say greater than 1500 commercial vehicles per day if you just observe, isn't it? These are the values we are having. What is the first one? 1.5 is a vehicle damage factor we have to take for this plane terrain, right? Which terrain you can say if you just observe? This is a plane terrain. One second. Let me just erase this and write. What is the first one? You can say that planar rolling terrain, right? Whenever it is a plane terrain or rolling terrain. And what is that next terrain? You can say it is your hilly terrain if you just observe, right? So this is 1.5, we have to take it here for planar rolling terrain, and 0.5 for this hilly terrain, right? And when the traffic is from 150 to 1500 CVPD, plain and rolling terrain it is your 3.5, right? Hilly terrain it is which one? This 1.5 you can say, right? Greater than 1500 you can say plain and rolling terrain it is 4.5, and what is this value? You can say this is your 2.5 you can say if you just observe, right? Isn't it? Is not like that you are having, right? Like that you are having if you just say, isn't it? Right? These are which values you can say if you just observe? These are which values you can say? These are your vehicle damage factor, right? Vehicle damage factor values, indicative values, right? What is the meaning of these indicative values? Just you have to follow these values if you do not know anything, right? You have to follow these values if you do not know anything, you can say, yes, na? Right? That is what the meaning of these indicative values. Okay, right? Now this completes your which one? This flexible payment you can say, right? Now we will be entering into which one? This next chapter, that rigid payment if you just observe. What is the next chapter we are discussing now? Rigid payment we will be discussing. Rigid payment and traffic engineering, right? That's it, right? With that all formulas of this highway engineering will be over, you can say, right? Like that. So that is your 271 na? And this is your 272 formula you can say. First one, what is the first one regarding this rigid payment if you just observe? Design life. Design life you can say, right? What is that a design life if you just observe, right? In the flexible payment design life we have given already na? Yes or no? What are those? Expressways 20 years, national highway and state highway 15 years, and other category roads 10 to 15 years for the flexible payment na? And for this rigid payment, what is the design life you can say if you just observe? Whenever it is your high volume roads, right? Whenever it is your high volume roads, whenever these are your high volume roads, these are taken for which one? This 30 years. And if they are low volume roads, what are these low volume roads? For this low volume roads, it is taken as your 20 years, you can say, right? It is taken as which one? This 20 years, you can say if you just observe, right? Yes, now, right? That is next to 273. Tell me, now tell me, what is that standard axle? Same, standard axle is the same only whether it is a flexible payment or rigid payment. It is a single axle with a dual wheel assembly na? Single axle with this dual wheel assembly only, right? Single angle with this dual wheel assembly only, right? And what is the standard axial load, you can say by default? If you just observe, nothing is mentioned. What is that standard axial load? If you just observe, that standard axial load will be 100 kilonewton, right? 100 kilonewton or 10.2 tons, or you can also take it as which one? This is 10,200 kg na. 10,200 kg, you can say, right? 10,200 kg, you can say, if you just observe, right? Is now, right? Like that we are having, right? Now, what are the other loads if we just observe? What are the other loads if we just observe? If we just consider it, this is your 273, 274. For other axials we have mentioned now. For other axial loads, what are these other axial loads if we just observe? First type. What is the first type? Maximum single axial load. Maximum single axial load, right? Maximum single axial load. Whenever it is your single wheel, what is it you can say? With a single wheel on either side, with a single wheel on either side, what is the condition? With a single wheel on either side, it is how much you can say? This is your 100 kilonewton only. And with a dual wheel on either side also, with a dual wheel on either side also, for rigid payment, how much it is taken? Same 100 kilonewton only, right? If you attended that flexible payment formula class, right? For flexible payment, what are the values we have given? If you just say, for flexible payment, what are the values you have given? If you just say, all of you, first one is your 65 and second one is your 80 kilonewton. Na? First one is your 65 and second one is your 80 kilonewton, you can say. But here for rigid payment, both are 100 kilonewtons only, right? That difference you have to observe, is all of you. Could you observe this difference, all of you? Yes, this difference you have to observe, obviously, right? This difference you have to observe, obviously, right? Now, what is that? Single axle with a single wheel on either side means this is what the condition, right? Left side and right side. This is the load. And single axle with dual wheel means left side 2 wheels and right side 2 wheels you are having, na? Only one axle, single axle with dual wheel assembly, like this we are having, right? So now, is it clear, everyone? Right. Now, tandem axial load, second one. What is it? Maximum tandem axial load. In case of your flexible payment, if you remember, that is 148 kilonewton, right? Maximum tandem axial load. That maximum tandem axial load comes to be this 186 kilonewton here, right? Flexible payment 148 and rigid payment 186, right? What is the third one you can say? Maximum tridem axial load, na? What is the tridem axial load? Maximum flexible payment 224 and rigid payment it will be 235, you can say, like that. These are the different loads we are having, right? These are the various loads for the rigid payment you are having, if you just observe. Yes, na? Like that. Is it clear, everyone? Once it is done, tell me. I'll try to move to the next one. Shall I move forward, all of you? Right now, so if we just observe that cumulative standard axial repetitions, right? 275, that cumulative standard axial repetitions, right? Others are as usual, na? That CSA will be as usual, right? What is that? 365 into A into, what is that you can say? That 1 plus R power n minus 1 divided by which one? This. Divided by which one, all of you? Divided by this R, na? Into, what is that you can say? That vehicle damage factor into lane distribution factor into, what is that you can say? That load safety factor, right? All these values already given, na? Yes, right? LDF and VDF we have to calculate in the same manner as that of which one? Flexible payment only, right? Same as what? Same as flexible only. And this rigidity factor also, right? Rigidity factor is equal to which one? This contact pressure by this tire pressure. And what is that? VDF calculations, right? VDF calculations, right? And LDF calculations, right? All these are same as that of your flexible payment only, na? And equivalent axial load factor, from that only vehicle damage factor comes into picture, right? And equivalent single wheel load, So these are all, which one, this is same as flexible payment only, no? So that is the reason I am not writing them again, right? I am not writing them again, right? Like that. And there is one more, these are the extra things we are having here. Apart from those factors, we are having some other factors here, right? What are these other factors? You can say, we just observe 276. What is that? You can say radius of relative stiffness. What is that? You can say radius of this relative stiffness. L is the symbol given, right? What is the radius of relative stiffness? L value you can calculate. L is nothing but your EH cube divided by this 12K into, what is that? You can say that 1 minus mu square whole power, how much? You can say that a whole power 1 by 4. Okay, whole power 1 by 4, right? What is that mu? You can say mu is the Poisson's ratio, right? Isn't it? Mu is which one? This is Poisson's ratio. Generally, if that Poisson's ratio is not given, how much you have to take? It is taken as your 0.15 if it is not given, right? If it is not given, you take it as 0.15. If it is given, okay, right? What is that? H, you can say H is your cement concrete pavement slab thickness, na? Yes, it is your which one? This is slab thickness. You can say, if you just observe, right? What is that K? What is that K? If you just observe, K is nothing but your modulus of subgrade reaction, na? K is nothing but your which one? This is modulus of this subgrade reaction, isn't it? Modulus of this subgrade reaction is at K value, right? Already we have mentioned it. Plate load test will be using for getting the modulus of subgrade reaction, if you just observe all of you, is not? And what is that E? We can say modulus of elasticity of concrete, right? What is the E? Modulus of elasticity of concrete. Modulus of which one? This elasticity of concrete. That is your E value. Now, so here what are they actually representing? If you just observe, what are they actually representing? If you just observe, L, what is that? A radius of this relative stiffness is representing. Suppose if you just consider it, let us say this is your beam, this is your cement concrete panel. Let us say this is your cement concrete panel, and you consider this as your H, and let us say the load is applied in which manner, all of you? Let us say the load is applied by means of this wheel over this small area. Let us say this is the load, wheel load P is applied, right? And tell me what is the radius of this loading area? The radius of this loading area will be small here, right? And whenever you are considering this in the plan view, whenever you are considering this in the plan view, right, what happens? Whenever you are considering this in the plan view, right, if you just consider this in the plan view, there is a possibility that a loading area will be which one? This small circular area, na? So the radius of this loading area will be small here, right? In the pavement design and in the highway material study, everywhere we have to consider small a means what? Small a is nothing but your radius of this loading area only, no? Yes, radius of this loading area only, right? Now, whenever that is the loaded area, there is a possibility of deflection over some other area, na? All of you. There is a possibility of deflection over some other area, right? Let us say that is your loaded area, and it is subjected to deflection over this area like this. When a loading is in the circular format, that deflection also must be in the circular format, aren't all of you? Yes, that deflection also will be in this circular format, right? The radius of this deflected area, right? What is the radius of this deflected area is called as what? Radius of relative stiffness, right? Sir, you can call it as radius of this deflected area, but why you are calling it as a radius of this relative stiffness? Because where you require stiffness, wherever the deflections are occurring, there only you require stiffness, or not all? Yes, there only you require stiffness, if you just observe, right? That is the reason it is a radius of the area where stiffness is required or where the deflections are occurring, right? Now tell me. So load is applied over this small area, this purple color area, and deflections are occurring over this blue color circular area. And what happens? There will be resistance also, no? Who will be resisting that load? Only the portion nearby this load will be resisting, na? So load is a circular format, deflection is circular format, therefore that resisting area also must be in this circular format, and definitely. So the radius of this resisting area is called as your B, you can say. So this is your 276. I will be writing that 277. What is that you can say? Equivalent radius of this resisting section. Equivalent radius of what? That resisting section, you can say. What is the symbol we are giving? Small b is the symbol we are giving for this, right? Small b is the symbol we are giving for this equivalent radius of this resisting section, right? Why that equivalent? Originally that tire area will be rectangular, elliptical, rectangular and curved, sides rectangle and at the ends it is curved, right? So but what we are doing for simplicity in the calculations, we are converting that into equivalent circular area. Yes, we are converting that into equivalent circular area, right? What is that you are getting? B. That B is equal to under root 1.6 a square. A is nothing but your radius of the contact area or loading area, plus what is the H? H is the thickness of this pavement, minus 0.675 times this H, or you can also take it directly as A, right? When we have to use the first one and when we have to use the second one? We have to use the first one if A is which one? If A is which one of you? If A is lesser than the which one? This 1.72 for H. So its thickness is higher, right? When the thickness is higher, it will be reduced, or it is otherwise. Like that, right? So A is the radius of this loading area, B is the radius of this resisting area, and L is the radius of which one? And L is the radius of which one of you? And L is the radius of what you can say? And L is the radius of your deflected area, right? L is the radius of this deflected area. You can say if you just observe, right? Like that. Is that clear, everyone? Yes, now? Once it is done, tell me. I'll try to move forward. Right. 277. This is your 278. What is that you can say if you just observe? Wheel load stresses expressions we have to write now. What are the stresses we are having? What are the various types of these stresses we are having, all of you, if you just observe? First one is your wheel load stresses. No? So stresses due to the wheel load. What are the second type you can say? Temperature related stresses. No? Temperature or a seasonal related stresses, if you just observe. What are these two types we are having? One is your warping stresses, right? One is your warping or folding or curling stresses, right? Second one is which one, if you just observe? What is the second one you can say? Second type of stresses are which one? This is frictional stresses, okay? Second type of stresses are nothing but your frictional stresses, you can say, right? Second type of stresses are nothing but your frictional stresses, you can say, right? Like that, if you just observe, right? So now 279, the nature of this wheel load stresses, right? First we will see what is that you can say, that nature of wheel load stresses. What is the nature of this wheel load stresses, if you just consider? We have identified three critical locations of this pavement, right? Whenever you are considering a panel, let us say, right? One side is your LX length, other side is your LY width. One side is your LX length and other side is your LY width. Whatever it is, right? Either it is a length or width, whatever it is, right? LX is nothing but your length and LY is nothing but your width, you can say, right? These are the symbols we are giving for this length and width of this panel, right? These are the symbols we are giving for which one? Length and width of this panel, all of you. Yes, na? Right. Now, so what is the nature of this stresses, if you consider? Nature of this wheel load stresses, at three critical locations we have identified. What are the three critical locations we have identified? One is your I means what? Interior portion. Next E means what? Edge portion. Right? Four edges are there, na? Four sides. And what are the other portions? You can say that C. What is the meaning of this C? You can say C means your corner portions, right? Corner portions, right? So under this, if you just observe, whenever it is that interior loading, whenever it is at interior loading, right, how that will be acting if you just observe. Suppose if the wheel load is acting at the interior portion, let us say this is your slab panel and it is subjected to load at which location, all of you, and it is subjected to load at which location, and it is subjected to arrear, sorry, okay, and it is subjected to load at which location if you just observe, 1 second. It is subjected to load at this interior portion, you can say, right? Whenever the load is applied at this interior portion, it will be bending is similar to that of what? It will be bending is similar to that of which one? This simply supported slab, na? It is bending is similar to that of your simply supported slab or not? Yes, it will be bending similar to that of which one? This simply supported slab, you can say, right? Whenever it is bending is similar to that of your simply supported slab, what is the nature of this stresses? At top we are having this compression. Yes, at top we are having this compression, and at bottom what is the nature of this stress we are having? At bottom what is the nature of this stress? Tension. At bottom this is the tension, because similar to that of your simply supported which one? This is slab, you can say. And second one, when the load is acting at the edge portion, what is its nature? Edge loading, if you just say. Whenever it is at edge loading, if you just observe, right, what is the edge loading, you can say, if you just say, it will be behaving similar to that of what? Whenever this is a loading applied, it is behaving similar to that of which one, all of you? Yes, it is absolutely behaving similar to that of your simply supported beam, isn't it? It is behaving similar to that of your simply supported beam, you can say, yes, na? Simply supported beam, right? Whenever the bending is similar to that of your simply supported beam, tell me what is the nature of this stresses if you just observe. Same as that of your simply supported slab only, na? What is the nature of this stresses at top and bottom, all of you? Top it is compression, and bottom it is which one? This is tension. That is the nature of this stresses, right? Like that. So it is a simply supported beam behavior, right? Now, what is the third one? You can say when the loading is acting at the cantilever corner portion. Whenever it is a corner loading, suppose let us say this is your beam, if you just observe it, the load is applied at this place, let us say this is your corner loading. Whenever it is this corner loading, right, is it not bending similar to that of your cantilever, all of you? Yes, it is bending similar to that of your cantilever, we can say, right? Whenever it is of cantilever in nature, what is the nature of this stresses at top and bottom? Exactly opposite to that of your simply supported, na? What is the nature of this stresses at top and bottom, all of you? The nature of this stress at the top will be tension, right? Simply supported, compression at the top, but here tension at the top, and bottom compression will be having, exactly opposite to that of those things we are having, right? Like that, isn't it? So here with this we'll be closing the session, right? With this we'll be closing the session, right? This is the nature of which one? This wheel load stresses we have seen, and in tomorrow's class the nature of this warping stresses, frictional stresses, and expressions for all the stresses we'll see. And after that what else we'll be seeing? And after that what else we'll be seeing? We'll be seeing that joints. Okay, with that it will be over, right? Yeah, Sainath, yeah, actually what we need to consider is this wheel load is critical at edge or corner, means we'll see, right, in that formula, right, whenever you are considering these formulas, now we can identify whether it is critical at the edge or corner, right? Whether it is critical at the edge or corner, right? But if you just observe, more effect will be there on the corner, okay? More effect will be there on the corner, right? That also we'll discuss, don't worry. Warping stresses, which one, where it is higher, where it is lesser. Wheel load stresses, where it is higher, where it is lesser, that variation also we'll study in the next class, okay? Don't worry, in tomorrow's class that point we'll study, okay? Tomorrow also at 9 PM it is, right? Don't worry, right? Don't worry, I'll tell you, right? I'll tell you Right, yeah, corner only correct, right? Corner is only correct, right? Yes, Sainath, corner is only correct, that is what I said, right? Corner is only correct, right? That is why you have to follow them carefully, right? Partha Chakrabarti book you have to follow, okay? Partha Chakrabarti book is in that book only it is given correctly. If other than that is given, it is wrong in any other book, okay? Sainath, right? You have to be careful. Whatever I have given in the classes, that is only correct, okay? You have to be careful. Tomorrow also I will be giving that, don't worry, okay? Don't worry. Right, I'll be closing the session. Thank you all of you. Good night.